Welcome to episode 07 of CipherVibe's end-to-end cloud security architecture course. Hybrid connectivity links cloud environments to offices, data centers, partners, and edge sites. Its main security challenge is preventing a fast private path from becoming a broad, invisible trust channel. We will connect its purpose, design boundaries, implementation path, failure modes, and evidence of effectiveness. Every cloud security layer relies on the ones around it. Hybrid routing intersects network isolation, zero trust, identity, DNS, logging, and incident response. A private circuit changes transport characteristics. It does not remove the need for authorization, segmentation, and monitoring. Treat the architecture as a chain. A trusted identity requests an action, a policy makes a decision, a workload or data service enforces it, and telemetry records enough context to investigate later. The first building block is choose the transport for the risk. IPsec VPNs provide encrypted connectivity across public networks and are often suitable for controlled site-to-cloud paths. Dedicated private circuits offer predictable routing and capacity. Use redundant, tested paths and document when transport encryption, provider isolation, or both are required. The second building block is control route propagation. Limit which prefixes each connection may advertise or receive. Separate environments and partners into distinct route domains, prevent uncontrolled transitive routing, and review route changes like firewall changes because an incorrect advertisement can expose far more than one subnet. The third building block is inspect and segment the connection. Place inspection and segmentation controls where they can enforce the approved paths. Govern private DNS resolution, avoid broad domain trust assumptions, and protect management protocols with identity-aware access rather than relying on a source address that arrived through a corporate circuit. The fourth building block is keep hybrid evidence complete. Collect tunnel health, route changes, firewall actions, DNS events, and flow logs from both sides of the connection. Correlate them with configuration changes so responders can distinguish an outage, an unintended route, an abuse path, and a normal failover. Use this reference pattern. Begin with an explicit policy that describes the permitted outcome. Enforce that policy at the closest reliable control point. Route decision and activity evidence to protected storage. Then give an accountable team a tested path to review exceptions, correct drift, and respond to violations. A defensible hybrid pattern uses redundant controlled links, scoped route tables, inspection at the cloud and enterprise boundary, private DNS governance, and centralized visibility across both environments. Implement this layer in a sequence that preserves evidence and limits blast radius. First, inventory sites, prefixes, owners, applications, and data flows second. Define separate route domains and route allow lists third. Deploy redundant VPN or private circuit paths with tested failover fourth. Apply firewall and DNS controls at interconnection boundaries fifth. Centralize routing, tunnel, flow, and change evidence prefer pilots with a named owner and rollback plan over an unmeasured organization-wide switch. The best rollout is one where a normal workflow succeeds, an unsafe path fails closed, and the team can explain the decision from logs rather than intuition. Security architecture fails most often through assumptions, not dramatic movie-style attacks. First, treating private connectivity as implicit trust second, allowing default routes or transitive connectivity without review third, sharing one wide VPN for production, development, and partners fourth, losing visibility when traffic crosses between teams or providers. A configuration screen is not assurance. Collect evidence that the intended control applies to the correct scope and that violations become visible. First, test normal failover and verify only approved prefixes remain reachable second. Review route tables, BGP advertisements, and firewall policy together third. Alert on tunnel changes, unexpected prefixes. And high-risk protocol use fourth. Exercise isolation of one compromised site without breaking every connection. Test both normal activity and a safe negative case in an authorized environment. Record the expected decision, the evidence location, the owner who reviews exceptions, and the rollback method. Repeat after platform changes, new integrations, or major shifts in business use. For a practical exercise, design a redundant connection between a cloud production network and a corporate data center that cannot transit into development. Use synthetic information or an environment you own or are explicitly authorized to administer. Deliver a one-page diagram, a concise control statement, a list of expected audit events, and one test for an allowed path plus one test for a denied path. This artifact is more valuable than a screenshot because it explains the reasoning behind the configuration. Before scaling this layer, ask 5 review questions. Which assets, identities, or environments are in scope? Who owns the desired state and exception decisions? Which enforcement point can reliably apply the rule? Which records prove the decision and retain enough context for an investigation? And how can the organization revoke access, contain impact, or roll back safely when a control fails? Good architecture makes these answers explicit and testable. The key lesson is that hybrid connectivity becomes dependable only when design, policy, enforcement, evidence, and ownership move together. Document the decisions you make, remove permissions and exposure that do not support a real requirement, and rehearse the paths that matter before an incident forces the lesson. Continue through the next episode to connect this control layer to the rest of the CipherVibe cloud security architecture.